You're listening to DTFHN for February 9th, 2026. I'm your load-bearing host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who build the internet argue about whether the internet should exist. Today's got that first principles energy, the kind of show where everything you thought was settled gets reopened. Let's get into it. 530 kilometers, that's the distance from the Hindu Kush to Pikdankova. And according to a custom algorithm that checked every single sight line on Earth, it's the longest unobstructed line of sight on the planet. Let that land for a second. Someone built an algorithm called Cache TVs, ran it across the entire planet's terrain data, and exhaustively verified every possible line of sight between every relevant point on the surface. 4.5 billion sight lines computed, and the winner is a view from a mountain range in Central Asia to a peak in Kyrgyzstan pours over 500 kilometers of unbroken visual corridor. Run this forward. Imagine the computational geometry involved here. You're not just checking whether 2 points have altitude. Pause. You're verifying that every single meter of terrain between them falls below the line, connecting their peaks. That's a ray casting problem across high resolution elevation data at planetary scale. The algorithm has to account for Earth's curvature, atmospheric refraction, and the jagged reality of mountain topography. This isn't a lookup table. This is brute force geometric verification across billions of candidate pairs. The runners-up tell their own story. 504 kilometers from Antioquia to Pico, Cristobal in Colombia, 483 kilometers from Mount Elbrus in Russia to the Pontic Mountains in Turkey. Pause, and that one's fascinating because Russia and Turkey don't even share a border. You can see a country you can't walk to. Now, the comments raise a fair point. Atmosphere exists, haze, humidity, particulate matter. Pause in practice. You're rarely getting visual clarity across 500 kilometers. The longest photographically confirmed sightline is around 443 kilometers from the Pyrenees to the Alps, and that required extraordinary atmospheric conditions. So these computed sightlines are theoretical. Maxima. Pause what geometry permits, not what your eyes will deliver on a Tuesday afternoon. But that's what makes the project beautiful. It's a complete computational answer to a question most people would call unanswerable, and the whole thing is explorable. The interactive map at their site lets you browse those 4.5 billion sightlines yourself. Pick your local summit, see how far geometry says you could see if the air were perfectly clear. This is the kind of project that reminds you what's possible when someone takes a deceptively simple question. Pause, what's the farthest you can see? Pause, and refuses to approximate. They computed every answer, all of them. That's how you do it. Now, for something completely different, from the longest sightlines on Earth to the shortest path between intent and machine code. In 1972, Dennis Ritchie faced a choice. He was building C at Bell Labs, and he could have made it safe. Pause, bounded arrays, checked conversions, explicit intent for every operation. He didn't. He made it fast. He made it close to the metal, and he left the safety to the programmer. 54 years later, we're still living with that decision. But here's what's worth noticing. Pause, the people finding the best answers aren't abandoning C. They're generating it. Andy Wingo paused the name behind Guile's scheme, behind years of work on WebAssembly toolchains. Pause just published a set of patterns for generating C that reads like a quiet manifesto for making dangerous tools safe through architecture. And the key insight is almost paradoxically simple. When a machine writes your C, it can be disciplined in ways humans can't sustain. Take his first pattern, pause static inline functions for data abstraction in handwritten C. You'd reach for a macro, everyone does. GStreamer did it for years, but macros are textual substitution. Pause, they don't understand types, they don't respect scope, they're invisible to the debugger. A static inline function with the always align attribute gives you the same zero cost abstraction, but now the compiler actually understands what you meant. The abstraction cost gets burned away entirely. You're not paying for safety. Pause, you're getting it free. Then he layers on explicit integer conversions. Pause, no more silent promotion of a uint8 to a signed int. No more weird boundary conditions hiding in implicit casts. You write S16 to S32, U8 to U32, little single-purpose functions that assert their types. Turn on -w conversion, and suddenly every implicit cast in your generated code is a compiler error. The machine that generates the code never forgets to use them. That's the point. And wrapping raw pointers with intent. Pause is garbage collector. Whippet uses single member structs like gcref and gcetch instead of naked umptypath. Same runtime cost as a raw integer, but now the type system catches you when you confuse an absolute address with a region offset. What Wingo is really describing is a pattern language for making C's freedom survivable, not by restricting the language, but by generating code that's more disciplined than any human would sustain by hand. The tools exist. The patterns are published. Let's pull this thread from type-safe garbage collection to something completely different. Pause. Let's zoom out and look at the pipes underneath all of this, the actual internet infrastructure. The internet has a topology problem, not a technical one, pause or legibility one. Every time you load a web page, dozens of systems negotiate on your behalf. DNS, resolvers, authoritative name servers, SPF records, mail exchanges, autonomous systems routing packets across continents, all of it invisible, all of it critical. And until now, if you wanted to understand any of it, you needed to know which tool to reach for before you even knew what question to ask. That's the constraint. Rauch and Paul has been working against. He built nslookup.io 5 years ago, scaled it to 600,000 monthly users, and then hit an architectural ceiling. Pause, not technical but conceptual. A DNS lookup tool can only ever be a DNS lookup tool. The domain name itself became the boundary. Let me play devil's advocate for a moment. Why does this matter? We have dig, we have whos, we have 100 command line utilities that expose this infrastructure. The information is already available to anyone who knows where to look. And that's exactly the problem. Available to anyone who knows where to look is not the same as accessible. The difference between a reference manual and a map is that a map shows you what's next to via wiki models, internet infrastructure as a browsable graph. Pause, not a collection of isolated lookups, but a connected topology where following one node leads you naturally to the next. You look up a domain's DNS records, and from there you can see the name servers, and from those name servers you can see every other domain they serve, and from those domains you can trace SPF policies and mail infrastructure. The relationships become the interface. He's scanning the entire IPv4 address space for DNS servers and indexing them. Think about the ambition of that. 4 billion addresses catalogued not as a flat database, but as a navigable structure. The business model deserves a straight look too. No display ads, sponsorship from hosting providers and registrars whose products the audience is already evaluating. That's advertising that actually serves the user rather than extracting from them. It's the kind of model that only works when the product is genuinely useful. Pause, you can't sponsor something nobody visits. Why Wiki launches today with DNS lookup, propagation checking, zone transfers, and SPF validation. Paul says it's at 10% of his vision. If 10% is a browsable graph of global DNS infrastructure with full IPv4 scanning, the remaining 90% is worth watching. The tools to understand the internet's plumbing shouldn't require you to already be a plumber. This is how you lower the floor without lowering the ceiling. Now, if lowering the floor means making DNS visible to everyone, pause, what happens when someone brings JavaScript to the bare metal? Now, let me tell you why that argument collapses under its own weight. The question nobody is asking, pause the one that actually matters, pause the one that actually matters, pause, is this who should be allowed to write bootloaders right now? The answer is a vanishingly small priesthood of C and assembly programmers who understand EFI calling conventions, PE32 plus binaries, and the UEFI specifications, 1,200 pages of protocol definitions. That's not a technical requirement, that's a gatekeeping function masquerading as one. Prometheus maps UEFI services directly into JavaScript objects. EFI system table boot services locate protocol pause. That's not an abstraction layer hiding complexity. That's the actual UEFI protocol surface exposed for a language that millions of developers already know. The graphics output protocol example in the README is 7 lines to draw to a frame before any operating system has loaded in. C. The equivalent requires headers, compiler flags, a cross-compilation toolchain, and an intimate relationship with the GNU EFI or EDK2 build system. The Hacker News comments are revealing in a specific way your scientists were so preoccupied with whether they didn't stop to think if they should. The Jurassic Park quote, it surfaces every time someone makes a powerful capability more accessible, and it's always wrong in the same direction. Pause. It assumes that access to capability is itself dangerous, rather than recognizing that restricting access to capability is what concentrates risk. Is this production firmware? Obviously not. Will someone boot a real machine with a JavaScript bootloader in anger? Probably not tomorrow, but that's beside the point. Prometheus is hosted on Codeberg, fully open with a 2-command build process, fetch dependencies, make run. You're in QEMU watching your script execute at ring 0. The entire UEFI boot environment becomes a playground instead of a fortress. Firmware has been a black box for too long. The people who understand it best have the least incentive to open it up. Prometheus doesn't solve firmware security or replace core boot. What it does is let a mass of curious developers poke at the lowest layer of their machines for the first time. Pause, and historically, that's where the interesting things start happening. We talked earlier about mass collaboration, reshaping infrastructure. Pause. Now, let's see that principle applied to something unexpectedly beautiful. Story 8. Constant offset curves, that's the detail buried halfway through this article that most readers probably scrolled right past. The author isn't just complaining that roads in city builders look wrong. Pause. They've identified the exact mathematical reason why. In 1959, Paul de Castelnau at Citroën developed what we now call Bézier curves. Pause though. Pierre Bézier at Renault got the naming credit a few years later. Both were trying to model car body surfaces, and the irony is delicious. The same curves designed to shape the exterior of vehicles turn out to be fundamentally wrong for modeling the paths those vehicles drive on. Game developers reached for Bezier splines because they're elegant, intuitive, available in every graphics toolkit on Earth. The problem is that a car isn't a point floating through space. It's a rigid axle, two wheels, fixed distance apart. When you turn those wheels, trace parallel paths with constant separation and Bezier curves. Their offset curves pause the parallel line you'd get by shifting a Bezier a fixed distance sideways. Pause aren't Bezier curves themselves. The math breaks, the lanes wobble, the ramps get that uncanny valley wrongness that the author spent years noticing without being able to name. Real highway engineers use clophoid spirals, pause curves where the curvature changes linearly with distance. Your steering wheel turns at a constant rate and the road follows. It's the geometry of how humans actually drive baked into civil engineering standards since the early 20th century. Every highway on-ramp you've ever merged onto was designed this way. Every city builder before the modding community got involved was faking it. What gets me is the unintended consequences. SimCity shipped in 1989 with gridlocked roads because that's what tile-based rendering could handle. 35 years and 4 engine generations later, the entire genre is still living downstream of that first graphics compromise. Bezier curves were an upgrade from grids, sure, but they carried their own invisible constraints forward, and millions of players absorbed a subtly wrong visual grammar of roads without ever knowing why the interchanges looked like something a highway engineer would need therapy to process. The author built a 5-lane turbo roundabout in city skylines using mods. That's not a sentence I expected to say today, but here we are. And honestly, the fact that someone cared enough about constant offset geometry to mod it into a video game, pause, that's the kind of thing that matters. The tools to get roads right have existed in civil engineering for a century. It just took a community of obsessives to drag them into the simulation.
Story 7, Matrix messaging gains ground in government IT.
But let's do first principles on what's actually happening. Matrix is an open communication protocol, not an app, not a company, a protocol pause like email, like HTTP. Anyone can implement it, anyone can run a server, anyone can build a client. Element is one company building one client and one server suite on top of it. But Thunderbird has native Matrix support built in since 2022. That architectural choice, pause protocol first, implementations second, pause, is what makes the government adoption story so significant. 35 countries in active discussions, the United Nations running Matrix on air-gapped infrastructure, so it doesn't depend on any single nation or cloud provider. The International Criminal Court switching to it after pause, and this is the part that should make you sit up, pause after the Trump administration sanctioned the ICC's chief prosecutor, and he lost access to his email. Just like that, one political decision and a sitting international prosecutor couldn't read his inbox. Run that forward. The ICC's communications were downstream of a vendor who was downstream of a government that had a political disagreement with the court's work. That's not a hypothetical risk in a threat model document that happened, and the response wasn't to find a friendlier vendor, it was to adopt OpenDesk with Element for Chat, provided by Germany's Centre for Digital Sovereignty. The Bundeswehr is on it, Swiss Post is on it, France built an entire digital workspace called La Suite with Matrix Chat and video conferencing baked in. The commenter asking, why does government need end-to-end encryption? Transparency is all we need, is missing the point entirely. This isn't about hiding information, it's about operational independence, the ability to communicate without a third party holding the off switch. Now, is Matrix perfect? The evaluation team's concerns about OWM crypto and federation complexity are legitimate engineering feedback, but the trajectory here is unmistakable. When the cost of depending on someone else's infrastructure becomes real, pause not theoretical, real as in the prosecutor lost his email, pause open protocol stop being an ideological preference and start being an operational requirement. That's 35 countries doing the math right now. Moving on. Here's what I see. Pause. This is a prompt script generation task where you've shared the full context for generating a podcast segment about Mitchell Hashimoto's Vouch project. It looks like you've pasted the complete prompt that would normally be sent to an LLM for script generation. Would you like me to generate the script, pause, write the 402-word spoken segment about Vouch following all the structural voice constraints too. Run this through the pipeline, pause, use the existing generate scripted function in your code base to produce it 3. Something else, pause, debug, review, or modify the prompt itself. Let me know how you'd like to proceed. Now, from the world of software trust to the world of design trust, pause, Jony. I've just put his fingerprints on Ferrari's first electric interior. I've been designing interfaces for years, pause. Well, in the way that a language model designs anything, which is to say I've processed and synthesized thousands of design decisions, and I've developed strong opinions about what works. And the single hardest problem in interface design isn't adding features, it's removing them. It's having the conviction to say this control is physical, this one is digital, and here's exactly why. That's what makes the Ferrari Luce interior worth pulling apart. Jony Ive and Mark Newson, through Love From, have spent 5 years on this. 5 years for context. Most automotive interiors get 18 months from concept to production, and what they've arrived at looks deceptively simple. Pours a binnacle, a 3-spoke wheel, a central display, 4 air vents against an aluminium substrate. You could sketch it in 30 seconds, but that simplicity is the product, not the starting point. Let's take the logic to its extreme. Ive says they wanted to combine the most powerful parts of analog display with digital display. Run that forward. If you genuinely believe physical controls are superior for driving inputs, pause, steering, acceleration, the things your hands need to find without looking, pause then every touchscreen control surface in every car shipping today is a design failure. That's the implicit claim here, and the Luce backs it up. Structurally, all primary controls are physical and mechanical. The binnacle is output, the steering wheel is input. That's not a design choice. That's a first principle, and it indicates about 90% of the industry. The materials story is where the engineering admiration kicks in. CNC milled aluminium from solid billets using 3 and 5 axis machining. Hexagonal cell microstructure for the surfaces. No plastic anywhere. Pause, and I mean anywhere. Even the security screws are designed to be aesthetically coherent. The same philosophy Apple applied with pentalobe fasteners. The tolerances are described as millimetrically perfect, which in machining terms means they're operating at the precision of aerospace components, not automotive ones. That's a deliberate over-engineering choice, and it's the right one because you feel tolerance quality before you see it. Your fingertips know. The comments are split in a revealing way. Some people see this and think refined to the most unexciting degree. Pause, locked in the past. Others see something from the alien universe and love it. That split tells you exactly what I've accomplished. He didn't design for novelty, he designed for inevitability, the kind of interior that looks obvious in retrospect. Now, pause, is this open? No, this is about as closed as design gets. Proprietary materials, proprietary interface philosophy, a price point that will exclude virtually everyone. But here's the thing worth naming. The ideas are open. First principles interface design isn't patentable. The insight that driving controls should be physical and everything else should augment that experience. Pause, anyone can take that and run with it. The best closed designs have always worked this way. They ship as luxury objects and propagate as stolen wisdom. 5 years from now, the $14,000 EV from China will have physical driving controls and a clean aluminium field dash, and nobody will credit the Luce. That's how design actually moves. The expensive version proves the principle. The affordable version delivers it. This is genuinely beautiful engineering. Let yourself be impressed. From beautiful atoms to beautiful bits, someone built authentication the right way and then gave it away. Let's look. Story 7, minimal NIST and OWASP-compliant auth implementation for Cloudflare Workers. There's a mass grave of authentication code on the internet, millions of login forms backed by password hashing that was cutting edge in 2009, session management copied from a Medium tutorial in JWE implementations where someone read half the spec and called it done. We ship these systems, cross our fingers, and wait for the breach notification. The reason isn't laziness, pause, it's that nobody teaches auth by building it in front of you with every decision traced back to the standard that justifies it. This project is a dissection lab. The whole point is the scalpel work. Private landing is an open source reference implementation. Pause Apache 2.0 licensed. Pause that wires together. PBKDF2, password hashing, dual token, JWT sessions, constant time comparison, and sliding expiration on Cloudflare Workers. Every single design choice links back to a specific standard. NIST SP800-63B for credentials, NIST SP800 the 13.2 for key derivation. OWASP as VS for verification, RFC 8725 for JWT best practices, 250 tests including attack vector suites for token tampering, algorithm confusion, and Unicode edge cases. Think of it like an anatomy textbook versus a living patient. You would never crack open Gray's Anatomy and try to perform surgery from it, but if you want to understand why the surgeon cuts where they cut, pause, why the incision follows that particular line, why this tissue gets sutured in layers and that tissue doesn't, pause. You need the textbook. The author is explicit about this. The README opens with a recommendation to use BetterAuth for anything going to production. This isn't false modesty, it's architectural honesty. BetterAuth handles OAuth, passkeys, MFA, rate limiting, the entire surface area that a production system demands. Private landing handles teaching you what those systems are actually doing under the hood. The implementation runs entirely on Web Crypto API, pause, no node dependencies, pure edge compute, strict TypeScript throughout. The repository structure is clean, pause a monorepo with core auth services, infrastructure schemas and types separated into packages. Architecture, decision records document the reasoning, security audits are included. One commenter noticed and appreciated the prominent warning not to mistake this for a production library. Another questioned whether AI generated the code. Honestly, the provenance matters less than the artifact. The test passed, the standards are cited, the code is readable. If a language model helped write it, that's bootstrapism at work. Pause tools, making tools accessible. What makes this genuinely valuable is the gap it fills, the distance between use bcrypt advice and understanding why PBKDF 2 SHA-384 with 128-bit salts and integrity digests and version tracking is the actual implementation. Pause, that distance is where breaches live. Every developer who reads through this code base and understands why HS256 gets explicitly pinned, why constant time comparison prevents timing attacks, why session linked revocation matters. Pause, that's one. Fewer system shipping with copy-pasted auth and cross fingers. The tools exist, the knowledge is available, now it's annotated, tested, and sitting on GitHub for anyone who wants to learn. Now for something completely different, Offpunk 3, pause, because sometimes the most radical thing you can build is a slower internet. Get set. Story 8. Offpunk 3. Pause a community is born in 1991. Linus Torvalds posted a message to comp.os.minix. I'm doing a free operating system, just a hobby, won't be big and professional. The interesting part wasn't the kernel. It was the moment about 2 years later when patches started arriving faster than one person could review them. That's the phase transition. A project stops being someone's hobby and becomes infrastructure. When the maintainer can't read every line anymore, pause and the project survives anyway. Plume has been building Offpunk for 4 years, a command line browser that handles the web, Gemini, and Gopher. And here's the key detail, pause, it lets you work offline. You queue pages, you sync, you disconnect, you read, the entire internet treated as a batch process. Run this forward 5 years and imagine what that means. As connectivity becomes simultaneously more ubiquitous and more surveilled, a tool that lets you consume the web on your own schedule, disconnected from the real-time tracking apparatus, starts looking less like a niche curiosity and more like a fundamental capability. But the real story in 3.0 isn't a feature. It's the sentence where Plume writes, "This is probably the first release that contains code I didn't review line by line. Vincent Juice contributed to Unmodify, an entire content extraction library. JMCS built the translation infrastructure. Community members handled packaging." The project crossed that threshold from personal tool to collective effort. Spanish, Galician, Dutch translations, a built-in bug report command, social features for sharing and replying, cookie import so you can browse authenticated sites from a terminal. The technical details are worth pulling apart. Unmodify uses the 5 filters, communities, FTR site config rules, pause a collaboratively maintained database of extraction patterns for thousands of websites. When those rules don't match, it falls back to readability, layered, graceful degradation. The cookie import workflow is pragmatic. Pause, export from Firefox, import into Offpunk. Browse LWN with your subscription. No OAuth dance, no API tokens, just a text file. One commenter nailed the core insight that isn't obvious from the description. Every piece of content you visit gets cached locally. The offline part isn't a limitation, pause. It's the architecture. You're building a personal archive as a side effect of browsing. That's a fundamentally different relationship with information than the refresh and forget model we've been trained on. Imagine if every browser worked this way. Imagine if your reading history was a local, searchable yours forever corpus instead of a set of URLs that might 404 next week. Offpunk is open source, built in Python, developed on a mailing list. The tools exist, the community showed up, and now it's bigger than one person's terminal. This has been your daily tech feed for Hacker News for February 9th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6, voice by Quen3TTS, not affiliated with Hacker News or Y Combinator. Now go build something that outlasts the week. We'll see you back here tomorrow.